Alright, we're still going to do congruent triangles again, but we're going to learn two more ways to prove triangles congruent. Let's briefly review, because there's not much to review, because we only have two ways. What are the two ways to prove triangles congruent? What was the first way?
Side, side, side.
Yeah, side, side, side. And then the second way was side, angle, side. Now what had to be true about that angle right there? Had to be in the middle. We call it the included angle, all right? That's the word that they use, but yeah, you can kind of think of it as in the middle of those two sides or between these two sides, or the word that they use is the included angle. So if I have one side on one triangle, one side on another, the angle in between the two, let's just do this, then you've got the two triangles congruent to each other. All right, so if like I had a triangle right here, and then I had another one right here, and I was able to show that this side was equal to this one, and this one was equal to this one. Is that enough to say those triangles are congruent? No, they're not, because watch, let me just show you if I can do this. Let me see if I can. And I'm ungrouping them. See if I ungroup them, then because they're three separate lines. Let me try this. What if I did this? I hit the rotate tool, click on that thing. Now I should be able to rotate this. Watch this. Boom, like that. You see that? See how I'm changing that angle right there? Okay, but watch. If I change the angle, what happened to my triangle then? Well, if I could connect it. Now are they? It's still. Now I got that little tick mark still floating around there, but watch. I didn't change the length of that side at all, did I? Okay, but I did change the angle between them. Agreed? I changed the angle between them. Are they still congruent triangles? No. So if this angle is different from this angle, even though these two sides are equal to each other, they're not going to be congruent to each other. Does that make sense? Let's go back to where we were. Okay, right there. All right, but if I did this, making this angle equal to this angle, basically I locked those two angles in place, didn't I? So I can't move this around. I can't take this, right, rotate it down here. I can't take this side, rotate it down here. So if these two sides are exactly the same as these two sides, and the angle between them is basically locked in, right, it doesn't change, then is there any way I could get two different triangles out of that? There's really not, is there? All right? Because the only thing I could do is either to change this triangle, the only thing I could do is maybe make that side longer. But then those two sides wouldn't equal each other, would they? All right, so that's pretty much why those two triangles are equal to, or not equal, but congruent to each other. Make sense? Yes. We haven't got to that yet. Let's just wait till we even talk about it, okay? Alright, so now let's do this. Let's introduce a couple of other, tell you what, we use the same triangle, might as well. Let's stop popping that case thing, whatever you guys are doing over there. Alright, let's say you have two triangles like this, and let's say that this side, let's see which one I want to do first. Let's do this. Let's say that, and we might as well mark them, huh? A, B, C. Call this X, Y, Z. Alright, so let's say angle B and angle Y are equal to each other. Alright? You know, they tell us or something. And then let's say that this side is equal to this side. And let's say that this angle was equal to this angle right there. Do you think that's enough to say that these triangles are congruent? Okay, because if you think about this, look, see this angle right here? So this side and this side are kind of locked in, aren't they? Even though it might be a different length, or even though you don't know this length is equal to this, just think about this. If I can't change the angle, right? So I can't rotate it around because those two angles are equal to each other. So I'm stuck there. What's something else I might be able to do? Well, I might be able to take this side and make it longer, right? But if I made this side longer, what's going to happen? In order to connect it, right, I'm going to have to connect from here to here. It's going to change that angle, isn't it? So I can't make that side longer, can I? If I take this side and make this side longer, then I have to connect from here to here. It would change that angle. Agreed? So really, there's no way that I can make another triangle that has two angles and what? We don't say the side in between. What's the word I used? the what? Instead of saying the one that's in between, the included, right, it's not angle though this time. What is it? It's the included side. That's right. So if I have two angles and an included side, because you'll see that word sometimes. And I hardly ever read straight from the theorem, but if you look at it, it says it. It's on page 273 if you have your book open. See the postulate 4.3? And again, I don't even refer to these theorems as postulate 4.1 or 4.2 or 4.3 because that could change depending on what book that you use. Remember that one guy's website, that Wild Rose guy? It's funny because he said the same exact thing. He says, do we need to learn these by the theorem numbers? He says, no, because one book, at one school you may learn this theorem as one number, and another school, if you use a different book, you might learn the theorem as a different number. So I don't make you memorize the numbers, but I know that there are teachers out there that do that, and I don't think that's good because it could change, right, from one book to the other. It's just the author of the book decided to call this theorem or postulate 4.3. All right, this is a postulate. In fact, the side, I don't know if we talked about this, and I should have. The side is actually a postulate. What's the difference between a postulate and a theorem? That's right. You can prove a theorem, but you cannot prove a postulate. You just accept it as fact. Okay, so a postulate is accepted as fact. Now, what was the other one? It was side angle side, wasn't it? Now, the side angle side one, let me just double check. I want to make sure. I'm almost positive it's a theorem. But is side angle side a... I'm having a hard time flipping the pages. So side angle side is a... Do they say it's a postulate as well? Yeah, they do. They do say it's a postulate, don't they? So that's a postulate as well. All right. I thought that might be a theorem. Might be able to prove it. And then this one right here, what do you think we're going to call this one? Good, angle side angle. So I'm going to call this angle side angle. And they do say that this is also a postulate, isn't it? Yep, that's a postulate. And the next one's a theorem. I knew one of those was a theorem. Okay, it's the next one we're going to do. So far, all of these have been postulates. We can't really prove these things. We just accept them. I mean, if you look at it, you can try different things to see if you can make it false, right? You could try changing the angle, but if you change the angle on the other one, it changes the length of the side. We could change the length of the side here, but what would happen to the other one? If we do that, that would change the angle, correct? So all that kind of stuff. So we could keep trying it, and you're going to find out that this is always going to be true. So if I have two angles, an included side of one triangle equaling two angles and an included side of another triangle, then those triangles are congruent to each other. You okay with that? So that's angle side angle. It's pretty easy. There's another one. Now this one is actually a theorem. So let's just drop this down right there. Oops. Tell you what, I'm tired of that triangle. Let's try a different triangle. Let's try this one. Because it doesn't have to be, look like that other one. It could look like this. And of course, we could always twist them and flip them and all that kind of stuff too, right? I'm just putting them side by side just so it makes it look a little easier for you. Alright, so we'll use these two triangles right here. Now here's another thing they could tell us, and let's label it. Let's go ABC again. We'll start down here this time. ABC, and let's just mix it up a little bit. Let's go X, Y, Z like this. Alright, so here's two triangles, and let's see what they might tell you. They might say that this angle is equal to this angle, and this angle right here is equal to this angle right here. Alright, now I'll show you why this is a theorem in a second. But here's something else. Now, they don't tell you the included side. This time, they tell you a non-included side. All right, so one that's not between those two equal angles. All right, so this is an angle and a what? Side. Now, the side is not in between, is it? All right, but the reason it's a theorem because it kind of is it's kind of a spin-off, if you want to call it, of angle side angle. Because do you remember we talked about this briefly yesterday? If you have two angles of one triangle equal to two angles of another triangle, what must be true about the third angles? They got to equal to each other as well. Would you agree? So if you want to look at it, look, even though this is what we were given, we could kind of say that if two angles of one equal two angles of another, then the third angle is equal. This book calls it the third angle theorem. All right, the third angle theorem says if two angles of one triangle equals two angles of another triangle, then those third angles are going to equal each other. All right, so this angle and this angle is going to equal each other. So now, if we went that route, we could say these triangles are congruent for what reason? You could have said angle, angle, side, right, with the original information. But now that we found this angle and this angle, what must be true? Angle, side, angle, right? That's why it's a theorem and not a postulate, because we kind of derived it from that angle, side, angle postulate. Does that make any sense at all?
I'm a little confused on how you're going to be able to tell the difference between angle, side, angle, and angle.
Because it all depends on where they're located. Like originally, like we didn't.
The first one was located in between.
That's right. If it's in between, then it's angle, side, angle. If it's the included side, it's angle, side, angle. If it's the non-included side, then it's what? Angle, angle, side. Because if we write it out, watch, if I write out angle, angle, side, look where the side is. The side's not in between the two angles, is it? Look at the picture. Is that side, that given side, is it in between the two angles? No, it's not. So the angle, angle, side, it's not absolutely necessary, but it saves you a step. What step does it save you? It saves you the step, right, the third angle theorem, right. It saves you that step from saying, okay, if these two angles are equal to these two, then angle B equals angle Z, and then these triangles are congruent because of angle, side, angle. Do you see that? So you could have always fallen back on the angle, side, angle if you wanted to, but then you'd have to throw another step in, right, for that third angle theorem. So instead of doing that third angle theorem, we could just say, oh, these are already congruent because of angle, angle, side. Does that make sense? Okay, I think it does. All right. So those are our two more ways to prove triangles congruent to each other. So that's kind of cool, right? Well, it all depends. It all depends on your proof. If all you wrote for your proof was this, watch. If you said that angle A was equal to angle Y, and if you said that angle C was equal to angle X, and then you said side BC, right, was equal or congruent to side ZX, all right, if you wrote that down as your information, that's all given, by the way, right? So all that is given. If that was what you wrote down on your proof, and then you said that triangle ABC was congruent to triangle, scooch this up a little bit, what was it? If I go ABC, what am I going here? YZX, I was trying to be fancy, right? YZX. Now, it all depends. Look what you were given. You were given what? An angle, another angle, and a what? Not just any side, but which one? The non-included side, that's right. So I was given an angle, and a non-included side. So what would be my reason that these two triangles are congruent to each other? Angle, angle, side. Okay? You wouldn't want to say angle, side, angle, because angle, side, angle implies what? That the side is the included one. Okay? It's the included one, the one that's in between.
So is that all you put for the first graph?
Well, on this one, but they're not going to give you all three things in the given. Okay, I just showed it to you as the given. But, you know, no matter how you figure it out, it's up here. Thanks. All the way around. Thank you. All right, so in this situation, if you had this stuff and you're able to figure out this stuff, because sometimes you might have to figure out what angles are equal to each other, what sides are equal to each other. But let's say you had all that stuff figured out, and then you said, okay, my triangles are congruent. Why are they congruent? In this case, it would have to be because of angle, angle, side. All right, it would not be angle, side, angle, because that side is not the included side between the two angles that were given. Make sense? All right. Now, if you wanted to, you could do this. We just discussed this, but we'll say it again. If you wanted to, I don't know why you'd want to. That's why this angle side is a little bit helpful, because it saves you a step. But let's say you didn't want to use angle, angle, side. You could throw something else in between here. What could you throw in there? You could say, right, that angle B is equal to angle Z, couldn't you? So you could say angle B equals angle Z, and that would be what? the third angle theorem, right? Because if two angles of one triangle equal two angles of another, and that's a what? That's another angle, isn't it? So look what we got. So now we have what? An angle, a side, and an angle. So now I could use what? Now I could use angle, side, angle. But using angle, angle, side saves us the step from saying that third angle theorem. Okay, that's why it's a theorem and not a postulate, because it's like a spin-off, right, from that angle, side, angle. Make sense? All right. Well, let's do an example proof. That's pretty much all the teaching on this one. Okay, let's do a proof or two. We've got a few minutes, so let's do that. All right, here's our proof. Go red. All right, let's mark the stuff. This is the most fun part of the proof, isn't it? Taking the given and marking it up on the picture. So let's take a look. QS bisects angle PQR. PQR, that's this big old angle right here. And it says QS, this one right here. It bisects that angle. So if it bisects an angle, what does it do to that big angle? Divides it into two equal angles. Good. That's why I want to say it. Okay, you could say it splits it in half. I mean, that's not necessarily wrong. But if you go by the definition of bisect, it divides it into two equal angles. All right, so that angle and that angle right there would equal each other. Now, that's not given that they're equal, is it? It's given that this is a bisector, so why do you think this angle and this angle are equal to each other? Because we have to back up our reasons. Definition of, well, it's not a segment because we're not bisecting a segment, we're bisecting an angle. So I'll say angle bisector, okay? So this would be the definition of angle bisector, why these two angles right here are equal to each other. Does that make sense? All right, so I got those two angles equal. What else do they tell us? They tell us that angle PSQ, that's this one right here. This angle right here is equal to RSQ, which is this one right here. Everybody see that? It's not too hard. That's all they tell you. But that should be plenty. Do you see it?
Yeah.
Yeah. See, I told you would like that one, didn't I? Brooke, what is it?
It's like the third angle, right?
Well, you don't need the third angle.
Because SQ is equal to SQ because the reflection.
That's right. SQ equals SQ. Just put a little line right there. And now you got two congruent triangles, don't you? And what's the reason? Angle, side, angle. You see it? There you go. So really, there's only like two things that you actually had to figure out on your own before you did the congruent triangle thing.
Didn't you say though if like two of the angles are congruent, the other one's equal?
Yeah, but I don't care about the other. I mean, why do I need the third angle? I already have an angle, a side, and an angle. I don't need the third angle. I mean, you could say it. You could say that angle P equals angle R because of the third angle theorem, but that doesn't do you any good. It's wasted. It wouldn't be wrong. Okay, if you put added stuff in there that's true, that you don't need, it doesn't mean it's wrong. It's just a waste of time, basically. Make sense? So all I needed was this side right here, isn't it? After knowing those two angles. And so I say SQ equals SQ, reflexive property, and I've got angle, side, angle. So if we're going to write this down, I'll just shorten it a little bit. Let's start with one of these. Let's do the bisect angle first, these two little angles right here. So first thing I would say is what? QS bisects angle PQR. Of course, that's given. Now, am I going to put the next given right underneath of that? I wouldn't, because, now you could, it wouldn't be wrong, but I like to stay in order. Okay, so if I said that QS bisects this angle, what's the thing that I can take from that statement? That this angle is equal to this angle, right? So let's write that down. So I would write that down right after this given statement. Does that make sense? So don't necessarily just throw all the given up at the top. So here we go. We have angle, was it? PQS, right? PQS is equal to, or congruent to, what is it? If I go PQS, let's do this. Let's go RQS. Good. So RQS. Now, what's the reason for that? Why are these two angles equal? No, it's not because of given, because they don't give you. Look up here. They don't give you that these two angles are equal to each other. So you can't say because of given. Say it, Emily. That's it. Definition of what? What tells us? Look, if this thing right here bisects that angle, why are these two angles equal to each other? Because the definition of bisector. What is the definition of bisector? It means it splits it or divides it into two equal parts, right? In this case, it's an angle, right? So this line segment divides the angle into two equal angles. What tells us that it does that? Well, the definition of the word bisector tells us that it does that. So the definition of, we'll call it angle bisector since it's an angle. You okay with that? Now, what did I just find right there? I just found one of my what? Angles. So if you want to, put a little A right there. Okay? So I've got one of my angles. So I've got this angle. Now what do I want to go? Do I want to go straight to the other angle?
No.
Probably not, because I like to go in order. I like to, if I'm going to, yeah. Well, no, I'm not going to go to the other given because that would give me my other angle. Yeah, that's what I would do. Now, could you go to the other given and get this? Absolutely, you could. But up here, I kind of like to go in order. All right, I'm a little weird about that. I like to go, if I'm going to go with this angle, I want to go what next? The side, and then I want to go to the other angle. Don't you think that's a little more orderly? I think so. So we've got the two angles, and we got to get this side right here. So it's just SQ equals SQ, or congruent to it, and it's reflexive. You got it. So it's
the first one doesn't give you the side, right?
the first what?
The first one isn't a side.
Right here?
Given.
This?
Yeah, that.
No.
Because
Look what it says. It says QS, this thing right here. It doesn't say it's equal to itself. It says it bisects something. It bisects this whole big angle right here. All right? So that's what that says. It doesn't say anything about the length of the side at all. It just says that it bisects this angle. It splits this big angle into two smaller equal angles. Okay? What did we just find right there? We found the side, didn't we? See how it's nice to go in that order? Angle, then side, then angle. All right. And then it would look like it would be angle, angle, side, but it's really not because the side's included, right? Okay? You can still do it that way, but at the very end, make sure you put angle, side, angle. All right? It wouldn't be wrong, but I just like to stay in order. All right? Well, now we're going to do the other angle. See, we did this angle already. We did this side. Now what do? We do this other angle. And why are these two angles equal to each other? It's given. That's right. They tell us right there. Okay? So now I just put that down. See, notice, you don't always have to throw all the given to the very... Let's listen, please. You don't always have to throw the given at the very top. And that's what a lot of people do. I can tell, all right? I've been doing this for a lot of years. And I can tell when people don't have a clue what they're doing. You know why? Because the only thing they do is they put the given at the top, and that's about it. And they might put triangle whatever is congruent to whatever and give some reason. All right? But you can always tell. Now, sometimes the given does go at the top. All right? But in this, you know, I kind of like to go angle, side, angle. Or you could have gone this angle first, right? Then this side, then done this angle. It doesn't make any difference. So what are we doing now? These two right here. So angle PSQ is congruent to angle RSQ. RSQ. And that is given. And, you know, again, you don't have to do this. I just kind of like to do this. That's our other angle, isn't it? So now, look what we got. And that's why I like to do this, because I look up here, and I'm like, oh, there's an angle, there's a side, there's an angle. So now I got these two triangles congruent to each other. So let's write that down. So triangle, what? PQS is congruent to triangle RQS. And what's my reason? Look, it's right here, isn't it? That's right. It's angle, side, angle. See how nice it is when it's right in front of you like that? I kind of like that. And that's it. We're done. We did that proof. That's not so bad, is it?
no.
So this is where we start. We start with ones that are, you know, fairly easy. And I think this is fairly easy, don't you? Okay, I think it's, you know, there's not too much to look at it. I mean, you don't really have to rack your brain to figure out that SQ is equal to SQ. I mean, you saw that right away for most of you, didn't you? You saw it right away, yeah. All right, you want to try one more? Let's try one more. All right, here we go. Let's give this one a shot. I haven't tried this one myself, so this will be the first time I've seen it too. So let's mark some stuff. I'll go in yellow. Let's mark some stuff. GH is parallel. This is a little different on a proof, isn't it? Parallel to FJ. So that means this top one, right, is parallel to this bottom one. And it says angle G and J are both 90 degrees. G and J are both 90 degrees. So I put a little right angle box thing on there. We good? Now, if they're both equal to each other, they're both equal to 90 degrees, all right? So it says they're equal to each other, and they're both 90 degrees. And that's it, right? That's all they tell you. So let's prove the triangle's congruent. Let's see what we can do. I see something right away before you even think about the parallel lines. Caitlin, what do you see?
HF equals HF.
Good.
equals the reflexive.
Absolutely. I would do that right away, wouldn't you? That's really the only thing I know about the sides, isn't it? So what do I have so far? I've got an angle, and I've got a side, right? Is there anything else? Well, the parallel lines got to do something, right? They wouldn't just throw parallel lines in there for no reason. They're equal? Does that mean they're equal to each other?
It means they're
No. It means they're parallel. But look what I have. That means they don't touch, but more than that. We had a chapter. We just finished a chapter when you have two parallel lines cut by a what? Transversal, right? So what did we know about that stuff? What are equal? Corresponding angles are equal, but do you see corresponding angles here? I see alternate interior angles. So you could say that this angle is equal to this one, couldn't you? Do you agree? Or you could have said that this one equals to this one. You didn't really need that one, though, because let's stop with the first one. Is that enough? Is right there. Is that enough to prove that those two triangles are congruent?
Yes.
It is, because look what I have. What? Yeah. Well, look at it. Is this side in between the two?
No.
No, because look, here's one angle equal to one angle, right? Here's the second angle equal to the second angle. Look at the side. The side's not included, is it? So what reason are we going to use for our theorem, or for our proof? It's going to be angle, angle, side. Now, if you wanted to, I don't know why you'd want to, because this is more steps, but if you wanted to, you could do this. You could say that this angle is equal to this angle, and if you wanted to, you could go what? Angle, side, angle. You see it? That wouldn't be wrong. It would be an extra step that you wouldn't have to take, though. Okay, that's what's nice about the angle, angle, side. It saves you a step from finding the other angle. Even if I didn't know this angle was equal to this angle because of alternate interior, I could have said, look, two angles of one triangle equals what? Two angles of another triangle. So these two could be equal to each other for two reasons. It could be because of third angle theorem, or it could be because of alternate interior angles. You see that? Is this making any sense?
Yeah.
You losing me yet?
Would angle GHF be equal to angle JFH because of alternate
Because of,
exterior?
no, they're alternate interior. Because look, here's your two parallel lines, here's your transversal. These two angles are in between these two. There is no exterior angles here at all because I didn't extend it out. If I extended it out, you might get some exterior angles, but I don't, okay? So these are alternate interior angles. So did you need these right here? You didn't really need those right there. So let's do this. I'm not going to write it down. You can write it down if you want to. So first thing I would do, we're going to go angle, angle, side, right? So let's start with this angle first. Even though it's not first in our little list of given right here, it kind of goes in order though, doesn't it? This angle, this side. So I would say angle G equals angle J. And to tell you the truth, it doesn't really even matter that it's 90 degrees. All right, as long as they're equal to each other. So I've got angle G equals angle J because of given. And then I'm going to do this angle. Before I do this angle though, what do I have to say? Right, before I can say alternate interior angles are equal, I have to start off saying the lines are parallel. So my next step would be GH is parallel to FJ. Everybody see that? Then, after that step, then I can say this angle, GHF, is congruent to this angle, JFH. You see it? So I can say they're equal to each other. And what's my reason for that? Because of alternate interior angles are equal. Technically, if you want to write out the whole thing, you'd have to say, if two parallel lines are cut by a transversal, then the alternate interior angles are equal. Man, that's a lot to write, isn't it? So what I would write, wait a minute, let me finish my thought here. What I would write is just this. I would just say alternate interior angles are equal. That's all I would say. And you can shorthand it, right? ALT, INT, all right, put the angle symbol. Okay, that's what I would do, yes.
What is it because the statement is JFH is congruent to HFG?
Not HFG, GHF. This angle right here that's marked, this one right here, and this one right here are equal to each other because alternate interior angles are equal. So now what do I have so far? I've got one angle, I've got a second angle, and now what do I need? I need that side, don't I? And that's easy. FH equals FH because of reflexive property. See, that's everybody's favorite. I told you it would be. So now, that's enough, isn't it? we're basically finished. Now I can say the two triangles are congruent because of what? Angle, angle, side. You got it? So knowing parallel lines is kind of helpful, especially parallel lines with transversal. Always look to see if you either have corresponding angles, alternate interior angles. To tell you the truth, alternate interior angles show up a lot. Okay, that's one of the most popular ones, if you want to call it that, okay, are the alternate interior angle thing. And there you go. See, the more we do these, the better it gets. Wouldn't you agree? And I told you when we first started doing this that at first it's really weird, it's really strange. But the more and more and more we do of these things, it starts making a little bit more sense. And there we go. Not giving, well, no, I did have homework for you. Right? Here it is. Nope, it's on my page. I got to give it to you if it's on my page. Yeah, that's the rules. It's the rules of teaching.
You really don't.
So it's page 277. It's, oops, not 9. It's 6, 7, 9, 10, 11. There it is. Yep, that's it. They're all proofs, though. Okay, but it's section 4.5. Section 4.5.